Okay, this is the video about graphing the sine and cosine functions, 8.3. And we study these because many things in life have a predictable repeating pattern, like the seasons of the year, tides, the orbit of the moon, things like that, and other things too have a periodic pattern. They repeat the same thing over and over again. Okay, we're talking about a sine function first. And if we graph the sine function around the circle, we've been talking about the sine going around and around the circle, but that's not that interesting because it just keeps going around and around. Most of the time when we graph a sine function, we get this. This is a sinusoidal wave down here in the blue, and we graph it in terms of x rather than s. Okay, so we don't graph it as far as its position on the unit circle. We graph it along like this. So the x values, the sine and cosine are both continuous from negative to positive infinity. They just keep repeating up and down. And the base period is 2 pi. Goes up and down, starts over again every 2 pi that x goes through. And it's symmetric with the origin. It's an odd function. Similar thing with the cosine function. It has a period of 2 pi. It starts at 1 instead of 0. It's out of phase with the sine function, but it looks the same, right? If we shifted this over left or right a little bit, we could get them to line up exactly one on top of the other, okay? And the graphing techniques we need to talk about when we look at these equations for what the numbers mean and how to graph that. And the first number we're going to talk about is this number in front of either the sine or the cosine. This number was 2 here. That signifies what's called the amplitude of the sine or cosine curve. Okay, so instead of going up just 1 and going down 1, when we have a 2 in front of it, it's going to go up 2 units and down 2 units, up 2 units and down 2 units. It does notice that it doesn't change the period at all. It just changes how high up or how low it goes. Okay? And when we talk about the amplitude, we talk about that's the difference between the maximum and minimum values. So for a normal cosine curve, it goes from 1 to -1, so that's a difference of 2. So the amplitude is 1. It's mostly, I think about it, is from this midline, how far up it goes from the midline, how far down it goes from the midline. That's the amplitude. Okay, so the amplitude, we use A for that variable for that. Okay, the next thing we need to figure out from these equations is the period. How often does this sine and cosine waves repeat? And if there's a number in front of the x value here, then that's going to change the value of our period. It's either going to make it smaller than 2 pi or bigger than 2 pi. Okay, so we know that the period normally is between 0 and 2 pi. And we put this bx in here and we solve for x, just divide by b there, we get this little 2 pi over b. X has to be between 2 pi over b. And this means that the period is 2 pi over whatever this number is. So if this number is 1, we just get 2 pi. If it's bigger than 1, we get a shorter period, right? Because we're dividing by a bigger number. If it's less than 1, we get a longer period because we're dividing by a fraction, right? When that makes a bigger number when we divide by a fraction. And when we graph these, we want to divide whatever this period is into 4 equal parts to get the values for which the sine and the cosine are at -1, 0, and 1, at their maximum, minimums, and where they cross the x-axis, is the x-intercepts. That's what we're looking for when we graph it. So we're going to graph a simple one here. It's got the 2/3 here next to the x. So I said what that 2/3 did to the period, but that was just like 15 seconds ago. So do you remember what that would do to the period? Would it make it larger or would it make it smaller? Most students would probably answer that it makes it smaller because a fraction is, makes things smaller. If you multiply something by 2/3, of course, it gets smaller. But this is what we're changing. We're actually not multiplying by this number. We're dividing by this number, right? Remember, we're dividing by 2 pi, dividing by this number. So if we're dividing by a small number, we're going to get a bigger number. And when you divide with a fraction, remember you have to multiply by the reciprocal of this. We multiply 2 pi by 3 over 2 and gives us 3 pi. And then we want to evaluate these functions at 0 and then 4 other values. Well, one of them is 0 and one of them is 3 pi, right? And the ones in between, we divide this into 4 equal parts. So we take 3 pi and divide it by 4. Okay? So the easiest way to do that is just do like I said. Start at 3 pi and 0. Put 4 under whatever the period is. Okay? So it's 3 pi over 4. The next period is going to be, the next point we're going to graph is 3/4 plus 3/4. That gives us 6/4. And when we reduce 6/4, we get 3/2. If we add 6/4 and another 3/4, we get 9/4. So we get these 3 points. And this one is just reduced. Normally that would be 6/4. So 3/4, 6/4, 9/4. And then 12/4 would be here when we would reduce that to be 3 pi. Okay, so that's the points we're going to graph, these 5 points. Okay, so when we graph the cosine at 0 is 1. The cosine here at the next point would be 0. Then it would go down to -1, back up to 0, and then back to +1 where it started. Okay, so we graph these 5 points. The first one and the last one are going to be exactly the same amplitude, right? They're just going to be, and they're going to be whatever distance the period is apart. Okay, so we got the graph 5 points. You have 1, 2, 3, 4 intervals. Okay, the calculator, you can do this with your calculator also. You can get it to look nice like this, but you have to do a couple of things. You have to change the window to be whatever the period is, or in terms of pi. So you change the window to 0 and 3 pi, that's the x values, and the y values can be just -2 to +2, just up and down 2. And you have to change this x scale on this, so that these little tick marks, the graph goes right through the tick marks. And our scale was 1/4 of what our period was. Our period was 3 pi, we divided that by 4. And when you graph it on the calculator like that, then it goes through the tick marks like that. And you know that that's every 3/4 pi is going to go be a max, a 0, a min, a 0, or a max. Okay? These are the 5 or 4 things you need to graph a sine or a cosine function. And this is with a b greater than 0. Okay, so we start by figuring out what the period is. And we start at 0, and then we figure out, okay, we mark off a distance of 2 pi over b, whatever that is. We divide that into 4 parts. So we put a 4 underneath here. So 4 times whatever b is, 2, or 4 times whatever b is. And I'll show you how to do this in just a second. Then we evaluate that, we figure out what those, with 0 and that, there's one value, then we figure out the 3 in the middle. So we get 4 intervals, but we're going to graph actually 5 points. Okay, so we get maximums, minimums, and a couple of x-intercepts. Okay. Then if the amplitude is something other than 1, then when our maximums and minimums have to go up or down to whatever that amplitude is. And we may want to draw some more cycles in it as we need to, or to make the graph look nicer. Okay, so this is a graph of sine of -2 sine of 3x. So to figure out the period, remember this number is bigger here. So is that going to make the period smaller, or is it going to make it bigger? Well, since we're dividing by a bigger number, that's going to shorten the period. And our period becomes 2 pi over 3. Okay, so we need to divide that into 4 equal parts. The first one is 0. The last one is 2 pi over 3. So if we put 2 pi over 3 and we put a 4 under here, we actually get 2 over 12 pi, right? 2 pi over 12, right? 4 times 3 is 12. And for me, it's just as easy. I don't reduce this or anything at first. I just go with that. Okay, so 2 pi over 12. Or you can probably reduce this one and make it 1/6, right? The 2 pi over that. 2 pi over 12 is the same as 1/6. So my first interval is going to be 1/6, 2/6, 3/6, and then 4/6. Okay, so this 1/6, 2, 6 reduces to 1/3. 3, 6 reduces to 1/2. 4, 6 reduces to 2 pi over 3. So that's how I do these to get easy numbers. So it's just like I just figure out what the smallest one is and keep adding that, and then I go back and reduce it. Okay, so the points we want to graph are 0, and at this pi over 6 is going to be 1. Well, it's not actually going to be 1 because we got to look at this amplitude here. We got to multiply. If we didn't have that -2 there, the amplitude would be 1. But with the -2 there, we multiply that by -2, and it's actually going to be -2. Then it's going to be 0. Then it's going to go the -1 times the -2 makes a +2, and then we're back down to 0. So this one's going to be inverted because of the negative sign there. So we plot the points 0, down to -2, back to 0, up to +2, down to 0 again. That's one complete cycle of our wave, one wavelength, one period of our graph there. And we can keep going on that if we need to. Do translations, do horizontal or vertical shifts. Remember when we were doing the horizontal vertical shifts, if we had x minus something minus the x or plus the x, it shifted it left or right. With sine and cosine, we call those phase shifts, and this expression x minus d is called the argument. And the vertical is pretty simple. We just add something and make it go up or down. It's not too tough. Okay, so this would be a typical problem you'd have with a phase shift in it. You'd have -1 and then the 2 sine of 4x plus pi. Okay, so we need to change this to figure out what the period is. We need to get this b number by itself. Okay, so we need to, whatever number is next to the x, we need to separate that from the x. So when we do that here, we remove the 4 from the x, but then we have to divide this number by 4, right? Because we're kind of reverse distributive properties, what we're doing here. So 4 times x and 4 times pi over 4 would give me pi. Okay, so this gives us our phase shift in here. This gives us what our b number for our amplitude, figure out our amplitude. The 2 is the the 4 figures out the period, the 2 figures out the amplitude, and the -1 means we're going to shift it down 1 unit. Okay, so we put pi over 4 here, so each of our units, our whole thing is going to be, our period is going to be pi over 2. Okay, that's our whole period because it's shorter. And then to figure out what our units are going to be, we divide this one by 4. Okay, so that'd be pi over 8 would be each of our little intervals. Okay, so pi over 8, so we're going to mark all our little intervals, and that's why they did the 1/8 pi's over here. Okay, then, but our phase shift, then we're going to go down 1 unit. So instead of being up and down on the x-axis, the midline is going to be the line y equals -1. And we're going to translate it, where the plus means we're going to translate it not to the right, but to the left. Okay, so this is going to start our first 0. Instead of starting here and being 0, we're going to move pi over 4 units to the left. Start here, go up 2. So when we go up 2, we get up to +1, come back down to 0, go down 2, because of our shift, we're down at -3, and we go up to 0, up to 1 again, and so on. Okay, so this is how you graph ones when they're phase shifted. We'll practice these in class, and I have some nice graph paper for you guys to use to help you on these. And it's not as hard as it looks when we do this, but I just want to introduce you to this in this video so you get an idea of what we're going to be doing in class. Okay, so answer the questions on the form below, and I'll see you guys in class.